Hello, welcome to my channel Science Endeavors. Today we are going to introduce the exciting word of calculus. Calculus is one of the most important tools in mathematics and science. Basically, calculus is the study of change, while algebra deals with numbers, equations, and geometry deals with shapes. Calculus helps us understand how things change and move. So we can actually define the calculus as the study of change. So it's very crucial in understanding different topics in physics, chemistry, engineering, and computer science. So calculus is divided into two main parts. So we have got differential calculus and integral calculus. The differential calculus studies rates of change like velocity or slope, while integral calculus deals with accumulation. So here we deal with the area, volume, or the total graph. So why should you learn calculus in the first place? So learning calculus is very important because it's a foundation of engineering, physics, chemistry, biology, economics, and computer science. Number two, it helps develop critical thinking and problem-solving skills. Number three, it lets you see how mathematics connects to the real world, from designing bridges and rockets to predicting population growth or analyzing business trends. So, in short, calculus is not just about solving equations, but it's about understanding how the universe works. So, once you learn it, you will start to see the patterns, motion, and relationship in everywhere. So, I sincerely hope that this course will be successful and enjoyable journey to you. So for today, I am going to do, before we dive into calculus, so we have to do some warm-up activities, that are gonna help us to review this necessary skills needed for us to start this journey. So here I'm having three parts. So the first part is about evaluation of different expressions, and the second part is about factorization and expression, and the third part will be expand and simplify. So these at the end of this session, you are going to gain essential skills, which some of them can are fundamental to calculus understanding. So let's start. So if you're new, you can just grab your pen and pencil so that we may do this together and enjoy. So as a student, you need to develop what is known as logical thinking and creative mindset. So whenever the best method, the ideal method to study calculus or any other mathematical subject is to prove things for yourself. So it's better to grab a pencil or a pen or even a calculator and see for yourself if whatever we are doing is making sense. So in that way, you're going to learn effectively. So the first part, it's we're going to do solutions. So I've got part A. So we are told to evaluate -3 to power 4. So negative 3. So we have got brackets, negative 3 to the power 4. So whenever there is, whenever I have brackets, it means that whatever is inside the bracket is actually affected by the power. So this power 4 is actually for the negative 3, for the whole negative 3. So we're gonna see how, when you see B is different from A, though we get the same answer, but they are different. I'm going to explain their difference in a few minutes. So B, it's negative 3 to power 4. So these brackets are crucial. Let's see how we can solve. So here we have negative 3 raised to power 4, which means it is negative 3 multiplied by negative 3 and multiplied by negative 3 multiplied by negative 3. So, and the answer here, negative 3 times negative 3, that's 9. 9 times negative 3, that is negative 27. Negative 27 times negative 3, that is 81. So here we get positive 81, but whenever we don't have the brackets, so in the second example we do not have a bracket, so this means that only the portion, only 3 is raised to power 4. So 3 raised to power 4, that is 81. But since we have got a negative sign in front of 3, which means the whole answer gonna be negative. So here you clearly see that the bracket is very important, plays important role. So for the first one, negative 3 is raised to power 4. But for the second one, it's actually, the 1 raised to power 4 is actually 3. So the negative 1, how can we prove this? Negative 3 to power 4 is the same as negative 1 times 3 to power 4. Actually, as you can see, I can actually factor out negative 1 and remain with 3 to power 4. So that's why at the end we end up getting negative 81 instead of positive 81. So that's very, very crucial. So let's see the second example. So the second example we have got, no, the third one, so C, which is 3 to power negative 4. So whenever a number is raised to a negative index, so a power is also known as index. So whenever a number is raised to negative index, we can actually get rid of the negative number by expressing it as a fraction. So here, negative, the general formula is, if you have a to power negative b, is the same as 1 over a to power b, which means you just write a fraction 1 over the number, and then the sign of an index changes. So this one becomes a denominator, and the sign of an index changes. So we can do the same with 3 to power negative 4, which becomes 1 over 3 to power 4. So 3 to power 4 is the same as 81. So this one becomes 1 over 81. Yeah, or we can actually simplify this. 3 to power negative 4 is equivalent to 3 to power negative 2 times 3 to power negative 2. Why? the indices will add to give negative 4. So 3 to power negative 2 is the same as 3 to power 3 squared plus 1 over 3 squared. So pardon, it's not plus, it's multiply. So here it's gonna be 1 over 9 multiplied by 1 over 9. So the denominator is gonna multiply, so we have got to 1 over 81. So it's basically the same answer. So let's for E, let me use this space. For E, you have 2 over 3 power negative 2. So the whole fraction is raised to power negative 2. So we can actually, whenever we have a fraction, for example, A over B raised to power C, this is the same as A to power C over B to power C. Actually, you can, the denominator and numerator both are raised to the index. So this is the same as 2 to power negative 2 over 3 to power negative 2, which is equal 2 to power negative 2. When we change that into fractions, it becomes as 1 over 2 to power 2. And this one, 3 to power negative 2, becomes 1 over 3 to power 2. So which is equal to 1 over 4 divided by 1 over 9. So, well, so this one, whenever we are dividing, we usually flip the, so here we have a complex fraction. So we have actually 1 over 4. This symbol is dividing, it's division. So 1 over 4 divided by 1 over 9. So whenever we are dividing a fraction, we usually flip it. So we have 1 over 4. So this division becomes times, and then it becomes 9 over 1. So actually we end up having 9 over 4. So pretty easy. The last one, which is F have 16 to power negative 3 over 4. How are we going to play with this? How can we simplify it? Now we can actually use some trick here. So we know that 16 is the same as 4 to power 2, right? Yeah. Or 16 is the same as 2 to power 4. So I'm going to take 2 to power 4. So wherever we have 16, I'm going to write 2 to power 4. So here 16 to power negative 3 over 4 is the same as 2 to power 4 raised to power negative 3 over 4. Now using the rule of index, or laws of indices, we know that A to power C raised to K is the same as A to power CK. So you just have to multiply the index with the power. I hope that makes sense. So here you're gonna have 2 to power 4 multiply by negative 3 to power 4, which means the index 4 gonna be multiplied by -3/4. So we know that this 4 will cancel, so we remain with 2 to power -3, which is the same as 1 over 2 to power 3, the same as 1 over 8. Yeah, so we are done with the part 1. It's just warm-up activities to remind ourselves of the essential skills that we need in order to tackle the whole the calculus. So in the second video, we're going to explain how we're going to do part 2 and part 3. Thank you very much for watching. If you like the content, you may subscribe and share. So see you in the next video.